In this tutorial, I'm going to go over everything you need to know to get 100 in the quiz tomorrow. All I'm going to do is I'm going to change the mass, and that's about it. So please don't memorize the answer. Okay, so let's consider an object. Let's say before we complete the table, let's consider a mass. Mass is, let's say, 10 kilogram. All right, and let's say mu s, which is 0.4, and mu k, which is 0.3. You understand that mu s is always bigger than mu k, and you also understand that the force of static friction is always greater than the kinetic friction. Because the static friction, you also understand that is less than or equal to mu s Fn. What does that mean? How does that look like? This. And then you also understand that Fk is equal to mu k Fn. And you also understand how that look like. If I change the color, red, and I'm going to call this one Fk. This one Fk, and this one is Fs. What's going on over here? You don't need to know that. Okay. We also know that, you also know a few other things, that the force of friction is proportional to Fn. Okay? What is then over here? Over here is the mu. Okay? So you also know that force of friction, mu s Fn, mu k Fn, or just mu Fn. So then mu is Ff over Fn. All right. You can put mu k over here, and then put k over here, and you put mu s over here, and put s over there, if you like. It is 9.8. So this is the weight is 98 Newton, and the normal force is also 98 Newton. Okay, with this, we'll be able to finish everything. All right, so one more thing, and that is, what is the maximum? Let's find it. What is that? This is called maximum. Maximum static friction possible, because this is Fs. And what is it? Mu s is 0.4 times Fn is 98, and that is 39.2 Newton. If you apply any force that is bigger than 39.2 Newton, then object will accelerate, because there would be a net force. If you apply anything less than 39.2, then object will remain at rest. Now the question is, what if you apply exactly 39.2 Newton? Then object gonna be in motion with constant velocity. So there is a transition from Newton's first law to second law. Less than 39.2, object at rest, Newton's first law. Exactly 39.2, constant motion, Newton's first law. More than 39.2, acceleration or increasing velocity, Newton's second law. Okay. Few things we're going to do over here. This is our applied force. This is force body diagram. This is the weight. This is the normal. This is, of course, the net force. This is total forces. This is acceleration. This is Ff. This is Fs. This is Fk. This is law. This is object at rest, constant velocity or increasing velocity. First, we're going to try with 0 Newton. Then we're going to try with 30 Newton, maybe, maybe 30 Newton, then 38.39, then 39 Newton, then 39.2 Newton, and then 40 Newton. All right, so let's start with 0 Newton. What are you going to get? All right, free body diagram. You have two forces at the y direction. They're equal in magnitude, opposite in direction. 98, 98. The net force is 0. Total forces acting 2. Acceleration is 0. Force of friction is 0. Static, yes. Kinetic, no. Law, Newton's first law. And of course, object is at rest. Now we're going to do the second one. Force body diagram. The four forces acting on it. Okay. I'm going to put the box so you're going to see it better. Four forces acting on it. They all are equal in magnitude, opposite in direction. Why is that? Because net force is 0. And of course, acceleration is 0. Net force is 0. The force is 4. Acceleration is 0. Force of friction all of a sudden become 30. Why 30? Because 30 is smaller than, of course, 39.2. If you apply any force that is smaller than the maximum friction possible, then immediately what you get is that, so that the object is at rest. The travel limit is 39.2. Anything less than 39.2, travel will be allowed to match up. All right, static friction, yes. Kinetic friction, no. Newton's first law, rest. All right, this one, of course, you have four vectors equal in magnitude, opposite in direction. So you now this is 39. See, even 39 is not enough to move. Okay, object maximum limit is 39.2. Even if you apply 31.999999, object won't move. Newton's first law, rest. Okay, finally you have 39.2 and you see object limit is 39.2. So object will move with no acceleration, meaning constant velocity. Object will move with constant velocity. Why is that? Because this is applied force 39.2. So the force of friction possible, maximum possible, is 39.2. So at the x direction, what is the net force? 0. At the y direction, what is the net force? 0. So object is motion. Why object in motion? Because there is this one and this one, they are the same. Okay. The table cannot apply more than 39.2. Okay. So law, Newton's first law, why? Because acceleration is 0. Constant motion. All right. Now I'm going to address this issue when I do the graph. Finally 40. So this time I'll do it over here. Maybe I can do it over here. So I have this is longer than FF and this is F normal, this is FG. All right, so the weight is the same, the normal force is the same, the net force. Okay, let's find the net force. To find the net force, we're going to have to write 40. Where does the 40 come from? Here we have to write FF. How much is the FF? Well, FF is mu k 0.398, so that is 29.4. so 29.4. All right, at the y direction, the acceleration of net force is 0, so you don't care about the y direction. All right, so you write F equal to ma. You want to write all the forces acting at the x direction. All right, all the forces. What are the forces? Fa minus ff is equal to m is 10 acceleration. Okay, so what is the net force? Net force is maybe you just write ma, doesn't matter, you can take care of it later. So 40 minus 29.4 is ma, which is of course F net. So what is it? It is 10.6. Net force is 10.6. All right, all the forces for acceleration. Okay, what is the acceleration? Acceleration is 10.6 divided by mass is of course 10. So 1.1. The force of friction is all of a sudden it become 29.4. It's kinetic because it's moving, Newton's second law. And of course this is increasing velocity. Okay, this is the time to do the graph. So let's do the graph. Before we do the graph, let's do the table. This is applied and this is force of friction. As 0, this is 0, okay? So I'm going to do this along the way, okay? So at 0, this is 0. Okay, let's pause update it. Let's do one more. 10, 10, 2 comma 0, 10 comma 10, 20 comma 20. All right, 39 comma 39. So 39 comma 39. So far so good. However, 39.2 is, so 39.2 probably here. So 39.2 gonna give you 39.2. So 39.2 right here. When you are 40, you are not here anymore. When you are 40, you are 29.4. So 29.4 here. So this is what happened at 40. 40, you are 29.4. So you connect them. All right. Okay, good. So this black line, what happened? Transition happened from static friction to kinetic friction, all right? From rest to motion. That's what happening on this black line. Object at rest. This object in motion. So this object in motion.